Hey everyone, today we'll be learning about a very important theorem which is De Moivre's theorem. So let's understand what it actually means and then we'll do one work example so that it will be easy for you to understand. Now, before delving into De Moivre's theorem, let's first understand what it is and why is it useful. Now, let me explain it to you with the help of an example. Suppose you want to find the exponent of any real number or any number. For example, if you want to find 2 raised to the power 5, we can find it out directly. It means 2 multiplied by 2 multiplied by 2 5 times, right? So we know that the answer for this is 32. Now, this is pretty straightforward and we can just find it out by calculation and multiplication. Now, but what happens when we have complex numbers? Now we know that complex numbers have things which involves iota, which is your I. So if you want to find out the exponent of any complex number, then the multiplication becomes very messy. Okay. So in that case, when we have to find the exponent of any complex number, we use the De Moivre's theorem. Okay. Now, for using the De Moivre's theorem, we know that any complex number z is expressed as a plus bi, right? Where a is the real part and bi is the imaginary part. Okay. We know that this is the general form of a complex number. Now, can we write the polar form of any complex number? Yes, we can write the polar form of any complex number. And we know that it is of the form z equals r cos theta plus I sine theta. So we express the complex number in a polar form, which means in terms of sine and cosine. So it can be expressed as this, where r equals the modulus. We know how to find out the modulus. So modulus, the value of modulus is a squared plus b squared. This is the modulus. And we know that theta is the argument over here, right? And we denote it with C, argument of C. So this form, we need to convert any complex number is in this form before applying the De Moivre theorem. Okay. Now, what the De Moivre's theorem actually states, let's learn about that. So, the De Moivre's theorem state that if Z equal R cos theta plus I sine of theta, then for any integer n, we have z raised to the power n. The value of the exponent of this complex number, z raised to the power n, will be equals to r raised to the power n multiplied by cos theta cos. Okay, I'll just erase it once and write it again. So we can say that the exponent of any complex number z raised to the power n equals r raised to the power n multiplied by cos n theta plus I sine n theta. Okay, so this is the general form which we write when we use the De Moivre's theorem. Okay, now let's take one example and understand it how we'll apply this in the questions. Okay, now suppose the question is that you have to find 1 plus I raised to the power 4. Now what we'll do, we have a complex number and we have to find the exponent of this complex number. So we'll be using the De Moivre's theorem for finding this out. Now the first step that we are going to do is, so we'll write step 1. The first step that we are going to do is we'll convert it into polar form. So let's convert the complex number into polar form. So when you'll convert it into polar form, for converting it into polar form, we need to find r. So you can find r under root of 1 square plus 1 square. So this is under root of 2. And let's find the argument, which is theta. So it will be tan inverse of 1 over 1, which will be pi by 4. So this is pi. Okay. So the complex form of this 1 plus I will be under root 2 brackets cos pi by 4 plus I sine pi by 4, right? So we have converted the complex number into its polar form. Now step 2 will be we'll apply the De Moivre's theorem. Now when we'll apply the De Moivre's theorem, what it states, any complex number when raised to an exponent or a power, it is of this general form. Okay, so here the value of n is 4. So this is the value of n here. So the value of n is 4 in this case. So what we are going to do, we are going to simply substitute the values. So 1 plus I raised to the power 4 equals under root 2 cos pi by 4 multiplied by 4. So this under root 2 will also be raised to the power of 4, raised to the power of 4. So under root 2 raised to the power of 4 cos pi by 4 plus I sine 4 multiplied by pi by 4, right? So you can solve this now, you can simplify it. So we know that under root of, let's simplify it on the next page. So we know that under root raised to the power 4 equals 4, and 4 multiplied by pi by 4 is pi. So this can be simplified as 4 cos pi plus I sine pi. Now we know that the value of cos pi is -1 and the value of sine pi is 0. So we'll just substitute the values. So what will be our answer? It will be -1 plus 0 I. So this will be equals to -4. So we have solved that the value of 1 plus I raised to the power 4 will be equals to -4, which is our final answer. So this is how we'll be using De Moivre's theorem in finding out the exponents of any complex numbers. Now we have a WhatsApp community where we discuss a lot of your doubts related to IB math, and we also share a lot of resources for your exam, like whether you are up in DP1 or DP2, it is beneficial for both of these years. So I'll attach the community link in the description box and you can check that out, and we'll meet again with a new topic in the next video. Till then, take care. Bye bye.